Systems of linear equation. In this video, we want to learn that if we have a system of linear equation, how we can solve the system. When we talk about systems of linear equation, it means that we have two or more linear equation with two or more variable. Every time we talk about the linear equation, we are talking about an equation like y equal 2x plus 5. This is a linear equation. But when we talk about the system of linear equation, that means we have two of these equations, which definitely has, each of them has two variables, x and y. And we want to solve this system. That means we want to find a solution that works for both of these equations, that satisfies both of the equations. If you have only two equations, if you have three equations, must satisfy all three equations at the same time. And this solution that there are on this we find for this system are considered simultaneously, which means that they have to work at the same time for both equations, not only for one equation. Okay. Since we have two equations, we have two variables as well. And when you solve this system, that means you want to find a number for x and a number for y that when you replace it for x and y in each of these equations gives you a true statement. And you know that the linear equations are, the graph of linear equation is a line. That's why we call it linear equation, because it always gives us a line. And when we have two lines, there are three cases when we have two lines, if we graph them. Sometimes the two lines cross each other, they have a point of intersection, and that point of intersection is a solution for that system with two equations. Sometimes when we graph the lines, we see that the lines are parallel to each other. When we have parallel, that means the two lines never cross each other. If they are not crossing each other, that means that system has no solutions. And sometimes when we graph two lines, we see that the two lines are overlapping. They are completely on top of each other. In this case, we say that they are intersecting each other at infinitely many points. So there are infinitely many solutions for this system. So the system that they have overlapping line is called dependent system, but not overlapping are called independent. If they have parallel lines, is also called inconsistent system. They are just a name for dependent or independent, consistent or inconsistent system. Now let's see how we can solve a system, how we can find a solution that works for both of the equations at the same time. One method to solve systems of equation is graphing. Just graph the line and see where the two lines cross each other. Let's look at this example. We want to solve the system of equation by graphing. Okay, for graphing, you know that the equation of the line must be in slope-intercept form. The slope-intercept form means y equal mx plus b. So every time you want to graph lines, make sure it's in a slope-intercept form because it makes it much easier to graph. And we don't need to find point for graphing. If it's not in this form, we can make it. We can just change the order and make sure that the y is by itself on one side, then start graphing. Because when we have it in a slope-intercept form, we can start with the y-intercept, and then based on the slope, we know how much rise and run do we have to find other points. For the first equation, the slope is 2, and the y-intercept is -3. That means we have a point of 0 and -3. That means on the y-axis, -3 is that's the first point. And based on the slope, which is 2, and it means 2 over 1 because there is no denominator. So the rise is 2 and the run is 1, which means rise is positive 2, means going 2 up. Run is positive 1, going 1 to the right. So start from negative 3, we go 2 up, 1 to the right. Next point, 2 up, 1 to the right. 2 up, 1 to the right. And then you can find as many points as you want and then start graph. So that we graph straight. Okay. Now we need to graph the second line. The second line is also in the slope-intercept form, so I don't need to make it. So the slope of this line is 1/4. Let me just choose another color. So the slope is 1/4. And then the y-intercept is 4. So I start from the y-intercept. And based on the slope, which is 1/4, you have to go 1 up, 4 to the right. 1 up, 4 to the right. 1 up, 4 to the right. Or if you don't have enough space on the right side, instead of going 1 up and 4 to the right, you can go 1 down, 4 to the left to find extra points. Okay. We need to make sure that this line is also 2 up, 1 to the right. Okay. And you see that's exact the point that they cross each other. And this is the point of intersection. And the point of intersection have x of 1, 2, 3, 4, and the y of 1, 2, 3, 4, 5. So the solution for this system is 4 and 5. That means x must be 4 and y must be 5. And if you replace x by 4 and y by 5, you will get a true statement in both of those equations. The only problem that the graphing method has is that you have to always graph it in a graph paper, and you have to make sure that the lines are the points that you find to graph the lines are very accurate. Otherwise, if a little lines, just going off not a straight line, you don't graph a straight line like mine and at the first time, you cannot find the correct point of intersection. Let's look at next example. We want to use graphing method, okay? So the first equation is in slope-intercept form because y is by itself, so it's ready to graph. And I know that the slope of this line is 3, and the y-intercept is -4, so I can start with it. -4, and based on the slope, which is -3, the slope is 3, that means I have to go 3 up and 1 to the right. So going 1, 2, 3 up, 1 to the right. 1, 2, 3 up, 1 to the right. 1, 2, 3 up, 1 to the right. Or 1, 2, 3 down, 1 to the left. And then connect the points. Okay, that's my first graph. Now I want to graph the second line. But second line is not in a slope-intercept form. So I have to make it in that form. How we can make y by itself? To isolate the y, I have to keep 2y, so I need to move 6x. So I'm going to add 6x to the both sides. So I will have 2y, which is equal to 6x plus 12. Then to make sure that the y is by itself, I have to divide everything by 2. So the y must be equal to 3x plus 6. Now it's in the slope-intercept form, and I can find the slope and y-intercept. So the slope of this line is 3. The y-intercept is 6. So I start from 6. And based on the slope, which is 3 over 1, it means going 3 up and 1 to the right. 1, 2, 3 up, 1 to the right. I don't have enough space on that direction, so I can go 3 down, 1 to the left. 3 down, 1 to the left. 3 down, 1 to the left. And now I'm going to grab this line as well. And I see that the two lines are parallel. And I know the two parallel lines never cross each other. So what is the solution for this system? There is no solution. Without graphing, I could also know that these two lines will be parallel and they never cross each other by just looking at the slope. Every time you have the same slope for the two lines, that means the lines are parallel. Even if you graph it, they are not going to cross each other. Another method for solving systems is called substitution method. For substitution method, we are going to solve one variable from one of the equations. When we say solve one variable, that means we want to keep one variable, x or y, from one of the equation by itself on one side and move everything else to the other side. And then after whatever we get after solving that variable, we are going to replace or substitute that one into the next equation. Okay? And solve that equation and find the variable. Let's look at this example. We want to solve the system by substitution. When you want to solve a system by substitution, you need to know that in one of the equation, you must have x by itself or y by itself. This is what you need. If you have it, you can just use it. If not, you can make it. Keep the x by itself or keep the y by itself. And it's up to you which x or which y from which equation you want to choose. And always choose the one variable that has no number because it doesn't give you fractions and it's easier to work. If you look at the part A of example 2, you see that the first equation is y by itself. So when I have y by itself in one of the equation, that means it's ready to be substituted. I don't need to move anything. And I can substitute this one, substitute x minus 6 for y into the next equation. Because y is equal to x minus 6. That means you can replace the y by x minus 6. So I'm going to look at the next equation, bring down everything that I have, but instead of y, I will put x minus 6. Now I have a linear equation that has only one variable, and it's x, and I'm going to solve this one to find the x. And to solve a linear equation, we need to simplify first. We need to drop the parenthesis, combine like term, and then find the x. So let's distribute to drop the parenthesis first. Negative 3 times x is negative 3x. Negative 3 times negative 6 is positive 18. Okay, combine like terms. 3x minus 3x is 0. So we just have left with 18 equal 18. Okay, x completely cancel. There is no x that I can find it. And I only have 18 equal 18. Every time you see the variable completely canceled and you don't have the variable into the equation, you have to look at the remaining equation. Is this a true statement or a false statement? Is 18 equal 18? So yes. So that's a true statement. And if it's a true statement, that means we can say this system has infinitely many solutions. Because you can replace any number that you want for x and y. Okay, so we can have infinitely many solutions. But if it was a false statement, like we had 0 equal 18, so we say no solution. Next example. We want to solve this system by substitution method. For substitution method, I need to have these four. One of the equation in one of the variable must be by itself. I should have x by itself or y by itself. None of my equations are in this form, so I have to make one of them in that form. And I always look for the variable that doesn't have any numbers in front. And I found this one. This is the easiest one. So isolating y from the second equation is the easiest one. And to isolate the y, you need to move 5x to the other side. So you get y, which is equal to 5x minus 32. And you need to, now you have y by itself. Y is by itself on one side. Now you have to replace this one for y into the first equation. Every time you find something from one equation, you have to go and replace it into another equation. Okay, so I'm going to write the first equation, 7x minus 6 times, replace the y by 5x minus 32, and it's equal to 77. Again, I have a linear equation with only x, so I'm going to distribute to drop the parentheses. 6 times 5 is 30x, negative 6 times 32, negative times negative is positive, and it's 6 times 32 is 192. Combined like term, 7x minus 30x is negative 23x. And I need to move 192 to the other side because I want to find the x. I want to have x by itself. So negative 23x must be equal to, and 192 minus 77, which is 115. Now, to isolate the x, I need to divide both sides by negative 20. Oh, that's negative 115 as well, because we have negative 192. You have to divide both sides by negative 23. And if we divide 115 divided by 23 is 5. We found the x. Now it's time to find the y. So we go back to the first equation, that we isolated the y in this equation again, and replace the x by 5. You can replace it in this equation or this equation or this equation, but this one, since the y is by itself, is the easiest one. So replace the x by 5. 5 times 5 is 25. 25 minus 32, which is negative 7. So x must be 5, and y must be negative 7. So the solution for this system is 5 and negative 7. Another method for solving systems of equation is called addition or elimination. Why do we call addition method? Because we need to add the two equations together to eliminate one of the variable. That's why it's famous to elimination method or also addition. So we want to eliminate, we want to remove one of the variables by adding the two equations. When we add the two equations, only time that the variable cancels each other is that when they have the same numbers, like 2x and negative 2x, 3x and negative 3x, 5x, negative 5x. They must have same numbers with opposite sign that they can cancel each other. Okay? So we have to decide first which variable we want to eliminate. Then we have to make sure that they have the same numbers in front of that variable. If they don't have same number, we can multiply the equation to get the same number. Then by addition, by adding the two equations, we can easily eliminate one variable and find another one. Sometimes we need to multiply both equations to get the same number. Sometimes we just multiply one equation to get the same number. Let's look at example 3. We want to solve the system by elimination. So first, I have to decide which variable I want to eliminate, or which one is easier. If you see one of the x or y doesn't have any numbers in front, usually that is the easiest one to eliminate. But right now, in part A, all of the x and y have numbers in front. So it doesn't matter which one we choose. And also something that's important, when you are using elimination method, make sure that the equations are lined up. X is under x, y under y, constant under the constant, and makes it easier for you to eliminate. Now, I want to eliminate x. Okay, if I want to eliminate the x, I have to have same numbers for x, but my first equation has 4x, my second equation has negative 3x. When I have 4x on the first equation, I expect to have negative 4x on the second one. And there is no way that you multiply negative 3 by something to get negative 4, because we only can multiply, not add or subtract. If you look at the second equation, you have negative 3x. It means that the first equation must have only positive 3x to eliminate the x. But we have 4x, and we cannot multiply 4. We cannot find a number to multiply 4 with to get 3x. So what do? In this case, we multiply both equations to get the same another number. I can multiply the first equation by 3, because I have 3x here, and I will multiply the second equation by 4 because I have 4 up there. And then I will get 12, which is the same number for x. But remember, when you multiply everything by 3, not only the x. 3 times 4x is 12x. 3 times negative 5 is negative 15y. 3 times negative 19. So 3 times 19, which is negative 57. For second equation, multiply everything by 4. 4 times negative 3x is negative 12x. 4 times negative 4 is negative 16y. And 4 times negative 9, which is negative 36. Now, if you look at these two equations, you see that the x are exactly the same. 12x, 12x, 12x minus 12x. And if you add these two, they completely cancel each other. Combine like terms. Negative 15y minus 16y. It's negative 31y. Negative 57 minus 36. Since both of them are negative, we have to add them. So it gives us negative 93. Now, to isolate the y, we just need to divide both sides by negative 31. And if we divide negative 93 by negative 31, negative and negative cancel each other, and 93 divided by 31 is just 3. After finding y, we go back to the equation and replace y by 3. Does it matter which equation? No. You can choose this one, or this one, or this one, or this one. Any equation you choose gives you the same answer. So I'm going to choose or replace this to this equation. So 4x minus 5y, which is 3, equals negative 19. Negative 5 times 3 is negative 15. To isolate the x, I have to add 15 to the both sides. Then divide by 4. And that's it. Now we have the solution. X is negative 1, y is 3. So in the next example, we want to use elimination method. Again, it's up to you. You want to eliminate the x or y, but something that's important, when you want to eliminate x, make sure the numbers for the x are the same with opposite sign. If you want to eliminate the y, make sure the numbers for y are the same. But right now, when I look at this equation, I see that in this equation, x doesn't have a number. It makes it easier because in this case, I don't need to multiply both equations. I can only multiply one equation. So I decided to eliminate x. To eliminate x, I have 3x on the second equation, which means I need to have negative 3x in the first equation. So what does it mean? I have to multiply the first equation by negative 3. Do I need to multiply the second equation? No, we just keep it the same. So multiply the first equation by negative 3. And just copy down the second equation. Then when I add these two combined like terms, 3x minus 3x gives me 0. Combined y terms, 18y minus 18y again gives me a 0. On the other side, 12 minus 12 is also a 0. Okay. I decided to eliminate the x by actually both of the x and y eliminated. There is no more x and y into this equation. That means I only have two options, no solution or infinitely many solutions. Since I have a true statement here, and I know that 0 is always equal to 0, that means I have infinitely many solutions. So infinitely many solution and no solution are a special solution that we can get for systems. When do we have no solution? When we eliminate both of the x and y, and we get the contradiction, we get two numbers on the both sides that are not equal to each other. When do we have infinitely many solution? When we solve and both of the x and y eliminate each other, but we get a true statement. 0 equals 0, 3 equals 3, 18 equals 18. So in this case, we have infinitely many solutions. To look at example 4, we have a system. We want to solve this system and find the answer. When it doesn't mention which method you choose, so it's up to you. You can use, if you want to use substitution method or elimination method. So for this system, I want to use substitution method. For substitution method, I need to have one of the equation in forms of x equal or y equal. None of my equations are in this form, but I can make one of them in that form, and I always choose that variable that has no numbers in front, and the variable that I will choose is y. So I'm going to make y by itself in the first equation. And to have y by itself, I just need to add 2x to the both sides to move 2x to the other side. Now I have y by itself. It means I can replace it into the second equation for y. Okay, now I just have an equation with the one variable x, and I can solve it. So distribute 4 by the parenthesis. So 8x minus 4 times 2x, which is 8x, negative 4 times 3, which is negative 12. 8x minus 8x is 0, so I just have negative 12, which is equal to 10. Okay. X completely canceled, and I have a false statement because negative 12 is not equal to 10. So if it's false, we say this system has no solution. That's a special solution, which is no solution. Next equation. This time I want to choose elimination method, and I want to eliminate y. If I want to eliminate x, so since I have 4x there, I have to have negative 4x on the second one, so I have to multiply the whole by negative 2 to gives me negative 4. But if I want to eliminate y, since I have negative 9y, I should have positive 9y, so I just need to multiply the whole by 3, because 3 times 3 gives us 9. positive 9. It doesn't matter. You can eliminate x or you can eliminate, I want to eliminate y this time. So I will write the first equation, not touching that, no change on the first one. But in the second equation, I will multiply everything by 3 to get positive 9. So 6x plus 9y, which is equal to 57. Now if I add two equations together, y cancels each other, so I just have 4x plus 6x, which is 10x, negative 37 plus 57, which is 20, and then divide both sides by 10, and the answer is 2. After finding x, replace it in one equation to find y. Okay, I'm going to replace it into this equation, with the second equation. So 2x, which is 2, plus 3y equal 19. 2 times 2 is 4. Subtract 4 from the both sides to it, because we want to have y by itself. And then divide both sides by 3, so y must be equal to 5. So the answer is 2 and 5. So this time we have a solution. It's not a special solution. Okay. We can also use systems of equation to help us and answer word problems. For example, it says the admission fee at an amusement park is $20 for children and $35 for adults. On a certain day, 212 people entered the park, and the admission fees collected totals of $5,740. How many children and how many adults were admitted? How many children and how many adults were admitted? So the last sentence tells me that I have to find a number of children and a number of adults. That means I have to find two things. So that means I have to have two variables. So you have to just name each variable. Okay, for how many children I'm going to use x. For how many adults number of adults I'm going to use y. You can choose C or A. You can choose any other letters that explain, but you have to define. You have to say, okay, what does X mean? What does Y mean? X is the number of children. Number of children. And Y is the number of adults. Okay? Then, after defining the variable, I'm going to go back to the beginning of the problem and try to write equations. We are not going to use guess and check to solve this kind of problem. We have to write equation, we have to set up a system of equation, and then solve the system. Why we need systems of equation? Because we have two variables. Every time you have two variables to find, you need to have two equations as well. Every time you have three variables to find, you have to have three equations. Okay. The first sentence, it says the admission fee is $20 for children, which is X, $35 for adults, which is Y. That means 20 for X, 35 Y. That is the money that they collected for every children and every adult that they entered the park. Okay, since they are the money part, so if you add them together, they must be equal to all the money that the park collected, which is 5,740. So make sure when you're writing equation, every equation have to have the same unit. So $20, $35, $5,740. Now I want to write the second equation. For second equation, I'm looking at the second sentence. It says on a certain day, 212 people entered the park. What does it mean 212 people entered the park? That means all the children and all the adults who entered the park are totals of 212. That means X, all the children, plus Y, all the adults together are 212. Okay. Now I have a system of two equations and I can solve this system using elimination method or substitution. I'm going to use substitution. I want to have y by itself from the second equation. So to have y by itself, I need to move x. So x going to the other side gives me negative x. And then I'm going to replace this one for y in the first equation. So 20x plus 35, replace y by 212 minus x, distribute, okay, 20x plus, so 35 times 212, which is 7,420, minus 35 times x, combine like term, so I have negative 15x, which is equal to, move the 7,420 to the other side. So I will have 5,740 minus 7,420. And the answer is negative 1,680. Divide both sides by negative 15. So x must be equal to 112. X is the number of children. So how many children entered the park? 112. Now I need to find the number of adults by going back to that equation and replace the x by 112. And then 212 minus 112 is just 100. So how many adults admitted? Just 100 adults. And the last problem, which is a mixture problem, it says Woody has one solution that is 28% alcohol and a second solution that is 46% alcohol. He wants to combine these solutions to make 45 liters of a solution that is 40% alcohol. How much of each original solution need to be used? Okay, the last sentence tells me how many variables I need to have. How much of each solution? So how many solutions do we have? Two solutions. So that means the first solution is my x and the second solution is my y. Okay, so x is the first solution and y is the second solution, which means x is the solution with 28% alcohol and y is the second solution which is a 46% alcohol. Okay. Go back to the beginning, read the problem again, and try to write two equations again because we have two variables. When it says Woody has one solution that is a 28% alcohol, so remember that we never keep percentage in our calculation when we are writing equation. Always have to change it to decimal. 28% means 0.28. 0.28 alcohol is for first solution. That means that for the x. So we have 0.28x. Second solution is a 46% alcohol, which is 0.46. So 0.46y. So the first solution, the second solution, and he wants to combine them, that means add them together to make 45 liters of a solution with 40% alcohol. That means 45 liters of means always multiplication. 40% means 0.40. And if you multiply 45 by 0.40, we get 18. So this is only the first solution. I need another solution as well. So how we can find the next equation? This is my first equation, and I need another equation. So when he says he wants to combine this solution to make 45 liters of combination, and we want to find how much of each solution do we need, okay? So we can write another equation based on how many liters of each solution do we have. So we have x liters of first solution adding by y liters of the second solution, and they must be together 45 liters. So my second equation is whole based on the 45, based on the liters of each solution. And my first equation is all based on the percentage of the alcohol. Again, you can use elimination or substitution, but at the end, you will get x, which is equal to 15, and y, which is equal to 30. That means you need 15 liters of 28% alcohol solution and 30 liters of 46% solution alcohol, which is the second solution.